Example 4 for taking a derivative using the power rule. Here we have a function that has exponents on the bottom and written in traditional form. First thing we want to do is bring these terms up so they're all written as what I call a one-liner. And so we have y equal 2x to the negative third minus 7x to the negative first plus 3x minus 11. As we apply the power rule, we again see a different notation here. This is saying take the derivative of the y function with respect to x. As I take my derivative, I'll take negative 3 times 2, which is negative 6, x to the negative fourth. As I move to the second term, negative 1 times 7 would be positive 7, x to the negative second. Again, I'm always subtracting 1 from these exponents. That's why that went to negative 4, and this went to negative 2. As I move to the third term, there's an implied 1 here, so 1 times 3 is 3. X to the 1 minus 1, which is 0. Anything to the 0 power goes to 1, so I have an x to the 0 here, which I don't write because it's just times 1. And then, as always, when you take a derivative of a constant, the constant drops out, becomes 0. And so my derivative is negative 6, x to the negative fourth, plus 7x to the negative second, plus 3. Traditionally, we do not write derivatives with negative exponents, so we have to bring those parts of the term down. As I bring them down, I would get dx, derivative of y with respect to x, negative 6 over x to the fourth plus 7 over x squared plus 3. Once again, I can turn this into one fraction if I find a common denominator. Common denominator would be x to the fourth, so I'd multiply top and bottom by x squared, and for this third term I would multiply top and bottom by x to the fourth. That would produce negative 6 plus 7x squared plus 3x to the fourth over x to the fourth. One of the responsibilities of any good calculus student is that you can recognize equivalent statements. With the last couple examples, I've tried to show how you can go from 3 terms into one big fraction. Be aware that that happens. As you're looking in the back of the book, they may give an answer like this, or they may give the answer as one big fraction. That's what they're doing. You have to be aware of equivalent statements. That's a responsibility. It's one of the staples of any good calculus student.